Hi everyone, it's Sorkin. Today we have a problem when we are given n cities. For example, in this example 1, city 0, 1, 2, and 3. And we need to find the cheapest way, go from the source city to the destination. In our case, the source city is 0, the destination is 3. So to go from 0 to 3 with the cheapest price. And another important requirement is that we need to do the trip with the k stops. So for example, in this case, the k is equals to 1. So we can make only one stop. Although let's say that this road from 0 to 1, from 1 to 2, and from 2 to 3 is 400, then we cannot pick that as a solution, because in this case we are making two stops. So we are picking this one from 0 to 1 and from 1 to 3, which is 100 plus 600 gives us 700. Okay, let's take a look at one more example. Let's say that we have 5 cities and we need to go from the city 0 to city 4 with one stop. So which algorithm we are going to use? We need to use one of the shortest path algorithms. In our case, we are going to use Dijkstra's algorithm, but a bit modified version of the Dijkstra's algorithm, because if we are going to use Dijkstra's algorithm as it is, it will not work for our case because it's a greedy approach, and in our case we need to make a k-stops, which Dijkstra's algorithm doesn't consider. Let's first try to use it as it is. So in Dijkstra's algorithm, we are maintaining a minimum heap that gives us the next shortest distance, and we are also keeping track of the visited nodes, the nodes that we have visited, so not to revisit them again. And we are setting the values to infinity for all other nodes, from our source node to all other nodes. From 0 to 0 it's 0, and to all other nodes it's infinity. Let's try to run the Dijkstra's algorithm first as it is. So we are starting from the 0, and so the next shortest path is to 1, which is 100. So we are updating this value, right? 100. And we are also adding that to visited. And the next one is from 100, from 1 to 2. So it's 100, right? So we are again updating this value to 200. Now we also visited 2. So, right, we also visited 2. But the problem here is that, so in this case, we will not revisit 2. It means that this path, we will not explore this path. And this is the only path that is in our case with the one stop that will take us to our destination, to 4. So instead of using our Dijkstra's algorithm as it is, we are not gonna, so we need to revisit our nodes, right? So we will abandon this visited Boolean. And also we are not going to use minimum heap. Instead of that, we are going to use a queue. And we are using a queue, and we are exploring every option that every path, every road, provided that provided two results. If it's less than, if the option that we have, if the road that we have, if we are making less than k-stops, and also that if the value is the less than current value or current price, right? Current price. Let's now try to run with the queue, right? Our algorithm. So first what we do, we start from the 0 again. Let's also remove these values. So we are starting again from the 0, and so we are the distance from 0 to 1 and the 2 is 100 and 500. We are updating these values right away, 100 and 500. And also we want to explore both options. So we are adding 1 to the queue, 100, right? 100. And also we are adding 2 to the queue with the 500, okay? So we have added that, and now we are first in, first out. We are taking 1, and we are exploring this option, and this option gives us what? It gives us 200 going to 2, right? It gives us 200 going to 2. So we are adding, so we are actually at this point, we have already exhausted one stop that we have. We cannot explore further, right? So we will not add any, so we cannot go anywhere from 2. So that's it. So let's explore the next one, 2 and the 500, right? 2 and 500. So 2 and 500 in this case, right? So what is where we can go from 2? From 2 we can go to 3 and 4. to 3, it is 500 plus 250, it gives us 750. And from this is the path that we need. So from 0 to 2, it gives us 500, and from 2 to 4, so this road, right, it gives us 100, so 600. We are updating this value also, and we are popping that from, we are taking that from our queue. Okay, first thing that we do here, we are creating a map of neighbors. So for example, for the 0, the neighbors are 1 and the 2. So we can go to 1 with the 100 and the 2 with the 500 respectively. So we are going over the flights and taking the source and the destination and the cost. If our source already exists in the map, if it does not exist, we are creating a new array list. If it already exists, then we are taking the value, we are taking the list for that source and adding our destination and the cost to the list. The next one, we are initializing minimum cost array, and we are setting the value for all other nodes to infinity. In our case, we are just setting that to integer max value. Then we are running our Dijkstra algorithm. So we are creating in our Dijkstra algorithm, first thing that we do, we are creating a queue, right? And we are starting with our source node, right? We are adding source node from source, and the destination from source to source is 0, and we are starting with our stops, and we are setting the minimum cost to source. So going from 0 to 0, it's 0, so we are setting that to 0. Now we are starting to explore the options. So we are taking from our queue whatever the value is there. For example, in the first one, we are taking the 0. So we are taking the current node, which is the 0 in this case. Current cost is 0, and the current stops in our case is 1, if we are considering the previous example. So if our neighbors map does not contain our node, so we are just skipping that. And if it contains, then what we do, we are exploring the options. So we are taking for the 0, for example, the neighbors are 1 and 2, right? So we are taking the neighbor node, which is, let's say, 1, and the neighbor cost, which is 100. And we are calculating the total cost. Total cost is current cost, which is 0 plus 100 gives us 100, right? And we are comparing with the neighbor node. So in this case, for the 1, it's infinity, right? So it's actually max value of the integer. So our total cost is less than that. So we are setting for the neighbor node, we are setting the cost, our total cost 100. And we are checking the current stop. If the current stop is more than 0, which means that we can go and explore the other options. Let's say in this case, we can go because we have one stop and we can add other nodes, right? So we are adding them to our queue. If it's not an option, then in that case, we are not adding those to our queue. And at the end, as we run our Dijkstra algorithm, so we set in our minimum cost array, we are setting all the values. At the last, we are checking if our minimum cost for the destination, right? If it's still infinity, if it's still max value, it means that we haven't reached our destination. In that case, we are returning -1. If we have reached our destination, we are returning the minimum cost destination, which is the price to go from our source to our destination. That's it. About the time and space complexity. For the time and space complexity is the V plus E, so number of vertices, which means that the number of nodes plus the number of edges, right? And the same is for the space complexity. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.